Welcome back to our third installment of Insights with Experts on Wind on the Academy of Metal Roof Innovations. On today's discussion with our panel of experts, we're going to dig deeper into the topic of wind uplift on standing seam metal roofs. What are the best ways to strengthen a roof? Which is the most economical choice? What type of clamps can be used to retrofit an existing building? And is thermal expansion something you'll need to keep in mind while securing your roof? All of this and more today on Insights with Experts.
Another point that we probably should make is the fact that the wind clamps versus additional purlins or joists often is a more economical solution, because quite often, now that we know that there's different wind zones on a roof, quite often the 5-foot purlin or joist spacing will work quite well for the main part of the roof. It's when you get into the edges and the corner zones that it may not work. And when you talk about the edges, let's just talk about the eave. If you do wind up going to a 2'6" purlin or joist spacing along the eave, at least you're using every bit of that member, all the way from one end of the building to the other. Now, if it's a metal building and you talk about edge zone going up the rake, and you've got a 25-foot bay, which is purlins, but let's say you got a 50-foot bay bar joist, if you have to go 2'6" up that rake with members, and your edge zone is only, say, 5, 6, 7 foot, you've got a whole lot of purlin or bar joist that isn't being used. So you've put a lot of money into that building when you really only needed that extra member for the first 6 foot. But obviously you can't let that member hang in the space. You've got to go to the next frame. And that's the beauty of the wind clamps. You're able, in a lot of cases, to keep that 5-foot purlin or joist spacing and just use the wind clamps to increase the capacity of that roof in just the areas that you need it. And so that's economizing the way you designed the roof.
What other ways are there to strengthen a roof?
If you go way back, you'll see where some of the manufacturers use 26 gauge steel on rare occasions. That doesn't work so well for wind, but most commonly they use 24 gauge steel. But then as wind loads started to get higher and people paid more attention to the permanent corner areas, some manufacturers started going with 22 gauge standing seam roof, which is probably about as thick as you'd want to go and still be able to roll it satisfactory. That's one approach that manufacturers. The other is to cut down your rib spacing.
Right.
So most are 24 inches on center, some go down to 12 inches on center.
But then that means there's more cost to that from an assembly perspective, right?
Right. There's always going to be some cost associated with it. But.
Yeah, not to mention the guy up on the roof who's got to get all that straight, right? I mean, from an engineering standpoint,
yes.
From an engineering standpoint, it's straightforward. As Dick mentioned, you got the rake area, which is an edge zone. Pretty straightforward approach from an engineering standpoint to just say, oh, I'm going to use 12-inch or 18-inch in this rake area for the the edge distance that comes out, which is usually anywhere from 10 to 30 feet, something like that, and then you transition back over. But when you're up there on a roof and you got all these different bundles of standing seam panels in different sizes, it may not be so easy to figure that out.
When I started back in 2008, the solutions was to do through fastening on your standing seam roofs, which, as we know, that restricts the thermal movement of that standing seam roof. So that tended to not be a very practical solutions for clients. And over time, those roofs did develop those leaks. So the clamp options is the one that I think works the best. But just having the technical numbers to know by adding X clamps in which zones, how much additional uplift do we get?
Dick, I know you've talked to me a little bit about, from your own testing that you guys have done, just the importance, I guess, of the right external seam clamp and sort of the impact on that. I know you guys have done some tests on things, that don't fit right. So what is what's your perspective and take on?
When we have insured clients that have existing buildings and the building was not designed properly for wind, maybe they didn't increase the resistance in the permanent corner areas, we have gone back and we've done tests for our insured clients. And we've had situations where Well, we got an existing building. It doesn't have any reduced purlin spans or anything like that. And this one in particular, we ran the test on the system as is, without any enhancement at all. It failed at 50 pounds per square foot. Then they had already installed some wind clamps, but unfortunately, on one of the buildings, unfortunately, the clamp that they used was a proprietary clamp that was actually for a different standing seam roof design, not for the one that they had. It didn't fit properly. And what you see here, it's a little bit exaggerated because we hadn't tightened it yet, but if you zoom in on this photo, you can see that that clamp does not fit well onto that seam. And there's a single bolt and it tightens over the seam, not into the side of the seam, which is preferable. We ran that test anyway, just because the client already had installed some of them. And we said, look, it's not going to work that good. Well, we went from 50 to 60 pounds per square foot before it failed. And that was not a good enough increase. So then we went ahead and said, look, I'm going to get a clamp, and it's the one you saw. I says, this one fits the seam properly. We're going to run the test again, exactly the same way. We went from 50 to 150 pounds per square foot. Because you're forcing the failure mode to change. And in this case, the clamp fits the seam properly, and that's the way to get all you can out of the existing roof.
You mentioned to me your international client base and how you somehow swapped buildings that were never in compliance and now are a part of the policy that you have with your customer, and how that is driving some of this demand for how to on the retrofit side. So I don't know if you want to talk a little bit about that.
Sure. The preference is really to use external seam clamps because you're really, if installed properly, you're going to increase the wind resistance and you're not going to create potential problems related to roof leakage. It's important that it be properly fitting, otherwise you're going to get only a marginal increase in strength. But I do want to talk about the thermal expansion issue, and here's an example of a one-piece clip on the left, and then you have a two-piece clip on the right. So if you're going to add an external seam clamp, if it's the one on the right and you're going to clamp that seam to the web of the top part of that clip, you're not going to restrict thermal movement because it's still going to be allowed between the base of the clip and the top part of the clip. But on the one-piece clip, if you clamp these two together, you're not going to allow that standing seam roof to slide along the internal clip, so you're going to restrain your thermal movement. So you want to, what some people call oil canning or dimpling, which could happen if you prevent the thermal expansion. The two-piece clips, you're fine. That allows you to provide for thermal expansion, yet you're still going to be able to clamp the seam to the top part of it.
Well, I hope everyone was taking notes and all that valuable information, but just in case, let's recap. When it comes to new construction, using wind clamps or external seam clamps can be a much more economical option over added purlins or higher gauge roofing material. When working with an existing building, wind clamps are an even better option. But remember, choosing the right clamp is vital. Otherwise, the increase in strength you gain may be negligible. And don't forget to take into account the type of roof clips you're working with. Otherwise, you may risk impinging the thermal movement of your roof seams. A huge thanks goes out once again to all of our experts and to FM Global, MCA, and MBCI. Next time on Insights with Experts on Wind, we'll be talking wind codes with people who know all about it. A team from the Regulatory and Economic Resources Department of Miami-Dade County. We look forward to seeing you then. Take care.